you probably know already without thinking too hard. Cool, we don't know either. I love it. All right, hopefully we kind of know an idea of paragraph proof. It's literally we're going to write a paragraph. So we're going to just do one of each, and like I said, we're just going to translate the ones we did yesterday, these ones, we're just going to translate them over into the different format. So we're not actually solving new problems today, we're just writing it in a different way. So, number one, we have two problems. Number one, we're going to do a paragraph proof. Which a paragraph proof means that we're using complete sentences. Okay, and then I'm just going to copy the proof that we did yesterday. I'm going to copy the beginning part, the picture. So we kind of had this sideways rectangle. We had K, A, G, and T. So this is just from yesterday, so if you want to just copy the given from yesterday and the proof, if you have it available to you right there. So I'm getting this problem just straight from this problem here, literally just copying this. So if you want to copy this given and this proof from yesterday over, if you don't have yesterday's notes very available, you can just copy from the screen. So our given was that AG, segment AG, is congruent to segment KT. And we had segment KA was congruent to segment TG. And what we were trying to prove was that triangle AGK is congruent to triangle TKG. Now, something I noticed yesterday is I gave a really big spiel about CPCTC because that's the whole reason I became a teacher, was cats pooping carefully in the corner. And then a lot of you really, really wanted to use that in your homework. But when we have triangles that we're proving congruent, that's where we stick to the side, angle, side, angle, side, HL, hypotenuse side. Okay, we only use CPCTC when we are trying to prove parts of the triangle. So we would end with like angles are congruent or sides are congruent. That's when we use that, CPCTC. All right, so for a paragraph proof, we already kind of had this planned out. So let's just remind ourselves. I'm going to flip back real quick. So first thing we always start with is the given. So we said that these parts were congruent as it was given to us. What was our second step? What did we bring in? The reflexive property. Good. And what side did we use was the reflexive property? That side that's in the middle, right? And then once we had that reflexive property, we then had all three sides marked. So we could say that they were congruent from side. So really we're going to just write this, but we're writing it in complete sentences. So we're going to use transition terms like first, second, third, or next, then, finally. We're just writing it in full sentences. So pretty much every line gets to be put into a sentence. If you want to be really basic, you say, we know this because this. Next, we know this because this. Finally, this because this. But we can add in some more interesting words if we want to make it a little bit more professional. My senior year, when you are a math major, you had to do like a thesis, and I did a capstone project. I didn't do a thesis. But I wrote a proof that was so professional that I got docked on it when I turned in my paper because my professor said I didn't like write down where I got it from, and he didn't believe me that like I made it up myself. So I was so good at it. I tricked my professor into thinking I was super, super smart. And I was. It was exciting. I'm not smart anymore, but I was. All right, so we're going to start with like a word first, or to begin, to start, or we are given. What do we want to? What do you guys want to begin with here? I want to start with first to start in the beginning. Anyone have an opinion? First? Okay. First. So we're going to use a capital letter because it's the beginning of a sentence. So first, we are given. And then we're going to list what we're given. So what things were we given? Segment AG is congruent to segment KT. And segment KA is congruent to segment TG. And that's the end of our sentence, so we put a period there. I forgot a comma. Where does a comma go in this one? After first. We're at transitional word. First, we are given this. First is a weird word when you see it 20 million times. All right, and then I'm just going to mark that up as we go. So this is my given. I'm using the same colors I used yesterday. If you want to use the same colors, you can, or you can just use 2 other colors. That's fine. So we knew AG was congruent to KT, and KA is congruent to TG. All right, then we need another transition word. We're going to the next step. When you look back at our proof, we had 3 steps. We did the first step now. We just translated this first step into a sentence. So we're going to the next step. So we need a transition word. We can use second, we can use next, we can use then, or now. Some sort of transition saying we're moving on. What do you guys want to use for moving onward? Next, okay. Next, we know. Okay, what's a statement that we know? When you go back to the proof, what did we write in our statement? KG is congruent to KG. Okay, so next we know segment KG is congruent to segment KG. And we need a because. Why did we do that? What was our reason? Because of the reflexive property. And again, we have a period because we're writing a paragraph. Okay, so again, I'm going to just mark that up really quick, just showing where these parts were. Okay, and then we have our last step. So it's nice if we can tell our reader that this is where we're ending. So we like to have an ending transition word like finally or last or in conclusion. In now we can say, or this leads us to believe this. So we want finally, at last, in conclusion. Sometimes I like to use therefore or thus. Thus makes you sound really smart. Thus, what do you guys want to use? Thus, so smart. Thus, we are able to say what is our concluding statement? What were we trying to say? Triangle is congruent to TKG, but we can't end the sentence there. We need to say why we can say that. So that's our statement. That's in that statement column. We need the reason. We can use because again if we're really boring and say because of. We can just continue to say that. We know this because of this. Or we can say like we're using this or by the blank theorem or by this property. So let's say using the, and what theorem are we using in that last one? Was it side, 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 angle, angle, side, angle? When we look at this, this is all sides. And technically, we do want to actually write out side, side, side. If you wrote SSS, I would accept that today. So that is our side, side, side theorem. Good morning. Period. So kind of the rule of thumb when you're doing a paragraph proof, most people, the way that their brains work is that they need to write this out first as a 2-column proof. So most people would do this step first. And then because we're like publishing a paper or we're making a really formal argument, then we would make it a paragraph proof. Okay? Generally speaking, you are not going to use paragraph proofs unless you are doing something that's more formal, something that you have to present, that you want to show somebody that you've taken time to do this. Okay? Or you might use a paragraph proof if you're presenting to someone who isn't familiar with proofs or familiar with the math, because they might understand it better when they're reading it out rather than seeing the different symbols. All right, we have one more. So this is number 2. Okay, number 2, we're going to do a flow proof. So if you think of like a river flowing, it's kind of like all rushing together. It's kind of joining in at different parts. Okay, so for our flow proof, we use arrows to show connections. And I actually really, really like flow proofs. This is more how my brain works than the 2-column proof, especially with problems that aren't necessarily linear, meaning it doesn't have to go in a certain order. Those of you that got stuck on one of the problems in your practice, it was because the given, they put given down like at step 4. Some of you like didn't catch that? You put like different things there, right? Okay. So when we do this, the flow proof is nice because we can kind of look at different parts and combine them in different ways and figure out how things are, we're getting to our conclusions. I really like it. All right, so number 2, we're going to copy the number 2 proof from yesterday. So if you have yesterday's out, we're just literally copying this picture and the given and the proof. We're not copying the 2-column proof, but we're copying this part. So those of you, if you don't have it or it's not in front of you, we started with like an X. And then we connected those into those 2 triangles. Doesn't have to be perfect. This is our F, G, K, P, and M. And then again, we're just copying the given, and we're copying the proof part from yesterday. So this is not a new problem. Same problem that we did yesterday. We're going to pretty much follow the same steps. We're just going to reformat it. Show what's connected. So we're given that what angle G is congruent to angle M. And we're given that K is the midpoint. Of FP. Okay, and what we're trying to prove was that FG is congruent to MP. Okay, so for our flow proof, we're not going to go like in an order. It's not going to look like in the two-column proof, it went 1, 2, 3, 4. 1, we did have that arrow saying that 2 came from this midpoint idea. We kind of just put that in there for our own brain. But this vertical angles, did the vertical angles come from the given, or did it come from the midpoint theorem? Or was the vertical angles kind of random? Yeah, it's kind of random. So it didn't have to go in step 3. We could have put this vertical angles. We could have even started the proof with it. We could have put this as number 1. We could have put this as number 2. It didn't have to be number 3. It did have to come before we did the triangles. So that's kind of the point of the flow proof, is that when we do this, we're showing where things go and how they're connected. So I'm going to start with my given. Angle G is congruent to angle M, and I'm going to write it off to the side here. Now when we do a flow proof, our statements get put into boxes. So I'm going to box that. And then our reason goes below it. We just write it a little bit underneath, kind of smaller. So that's our given. Okay, again, I'm going to color code this a little bit like we did yesterday. So I did this one in blue. Just that way we can see that connection between the two if you're looking back and forth. So G was parallel to M. Not parallel, congruent. All right, now my other given isn't more important than this. It's not less important. One didn't come before the other. These could have been switched around. So they're going to go on the same level. So I'm going to write K as the midpoint of FP over here next to it. It doesn't matter which one's first, so we're not making one above or below. So K is the midpoint of FP. And again, that gets put into a box. I like to draw my boxes after I write it. Otherwise, it's too hard to squish everything in. Okay, and that was a given. So again, we write that word given underneath. Now, we were able to do something with that midpoint. What did we come up with after the midpoint? If K is the middle of FP, what do we know about the two parts? Yeah, we knew that the two parts are congruent. So this leads to the next thing. So I'm going to draw an arrow just from this. It had nothing to do with the angles. It only had to do with the midpoint. So I'm drawing an arrow to my next box. And my next box comes from that idea of the midpoint, that FK is congruent to KP. That came directly from this idea of having a midpoint. And in fact, that was our midpoint theorem. Okay, if you want to color code that like we did yesterday, this one was our orange one. If you didn't use the same colors, you can just look back at yesterday and see what colors you used. But we said this was the same as this. Okay, once we use the information we're given, the last thing we do is, if we aren't ready to have three parts of this that we can say are the same, we can then use vertical angles or reflexive property. In this picture, which one are we going to use, reflexive or vertical? Vertical. Now, vertical angles just comes from this picture. It's not connected to this. It's not connected to this. It's just its own separate thing. So we're going to add that in on the other side over here. So angle. And remember, we have to use three letters for it. So we used GKF yesterday. Is congruent to angle. And we said MKP. Sorry, I keep moving my camera. I have to see what we wrote, because we wrote it a little different than I did last year, and that's okay. Okay, and that was vertical angles. Okay, again, if you want to shade that in, keep saying the word again, and mark that up. All right, now that we have this information, can I say that this triangle is congruent to this triangle? Yep. So we said triangle GFK sorry, you couldn't see what I was doing. Triangle GFK is congruent to triangle, we said MPK yesterday. And which theorem was that? Was it side, 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 angle, 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 side, or hypotenuse leg? Angle, angle, side. So AAS. So what I need to connect to this is I should have an angle connecting to it, an angle connecting to it, and a side connecting to it. So where's one of my angles that we started with? The given, right? That's one of the angles. Where's my other angle? My vertical angles, and then my side was right here at the midpoint theorem. So all three of these are combining into the same idea that these triangles are congruent. Now that I know the triangles are congruent, we can now say that the two parts are congruent. FG is congruent to MP. Okay, since I already used angle, angle, side to prove that the triangles are congruent, this is when we're going to use the cat's pooping carefully in the corner. CPTC. CPCTC. Did I say it right? Yeah. Okay, so a flow proof, it's saying the same things. If you look back, we have the same number of steps over here as we do here, but it's showing like, oh, this is angle, angle, side, because here's the angle, here's the angle, here's the side. It's connecting them rather than looking at it linearly as like a 1, 2, 3. It's showing how things combine to make those work. That's why it's called the flow proof.